Good morning from Milan. I'm Alessandro Lanza. I'm Executive Director of Fondazione Eni Enrico Mattei. And I will say just a few words of introduction, then Professor Galeotti will add some more context to the presentation. It's a pleasure for the second time we have been blessed by the presence of Dr. Jorge Blasquez, who is a senior advisor for the energy transition of BP, which has been so kind once again to take his time, his precious time, to share with us some thoughts about what one of the greatest companies in the world in oil and gas is elaborating on energy outlook. That means energy transition and all the rest. So I need just to add once again our gratitude for Jorge to take the time to discuss with us. The organization is very simple. It's the following. I've already finished my presentation. Then Professor Galeotti will add some more consideration. Then Dr. Blasquez will have 30 minutes. Then we have Elisa Scarpa from Edison that will discuss for about 15 minutes. And then the last 15 minutes are for comments. And for comments, there is a general rule, please, that you can write your comment, and then we will filter to some extent your comments. And Professor Galeotti will report to us your comments, and Dr. Blasquez will reply. I have finished my job. I've been as short as I could. Marzio, please.
Good morning. Welcome and thank you for attending this webinar. It is the second webinar that we host here concerning the BP Energy Outlook, and for the second time we are very pleased to have a friend, a colleague, a very valid energy economist, Jorge Blasquez, who's a senior advisor for the energy transition and system analysis at BP. And the presentation will be followed, as Alessandro just mentioned, by a discussion from Elisa Scarpa. I would like to mention that Elisa is an old friend of Finn. She also was a researcher here years ago, and she's Deputy Director of Market Strategy and Structuring at Edison of the EDF Group. As Alessandro said, 30 minutes, then 10 to 15 minutes for Elisa, and then we will collect a few questions that you should write in the chat so that we can then take a look at them, select them in case, and ask Jorge. We will read them aloud, and Jorge will reply to them. So thank you very much again, and Jorge, the floor is yours.
Well, thank you very much. Thank you for the invitation, Alessandro. Thank you for the invitation, Marzio, and thank you to the Fundación and Elisa for the opportunity to present the energy outlook. Before starting with the presentation, I want to explain what this document is intended for. By the way, it's available online, so all the charts, all the information, all the numbers, if you're interested, can get it free at BP webpage. So the idea is not to forecast the future, because we know we cannot predict the future, but to try to understand what are the risks and opportunities of the energy transition. So this presentation is not about predicting or forecasting, it's to try to highlight what are the challenges and opportunity for the energy transition. Having said that, and make this initial clarification, let me move to the following slide, which is just the plan for today, which is 5 points. First is the two scenarios that we use to explore the energy transition. a little bit about the economic content, what are the common trends that we have found in these two scenarios, what are the variables that are very different in these two scenarios, and then what is needed to accelerate the energy transition. So these are charts representing the two scenarios that you can see here. So the green line represents global emissions in what we call current trajectory. This is a scenario that tries to capture the broad pathway along which the energy system is traveling today. So more or less it's a scenario that tries to replicate what is going to happen with emissions and all the rest of variables if technologies, policies, and social preference are consistent.
Jorge,
we have
sorry to interrupt
yes.
you. We are not seeing the presentation.
No? Let me then.
You should share your screen, I think.
We see your nice face.
So can you send me the link again for sharing the screen, please? Now?
No.
Sharing my screen. Stop sharing my screen. Okay, so my screen, here it is.
Yes.
Here it is. Yes.
Here it is. Perfect.
Okay.
Are you seeing them?
Yes.
Two scenarios.
Okay.
Yes.
Two scenarios to explore the energy output.
Okay. So the green line, which is represented here, you can see here, represents the current trajectory and emissions in what we call current trajectory, which is a scenario that represents the try to capture the broad pathway along which the energy system is traveling today. So it's a pathway that tries to show what happened with the energy system if technology, policies, and social behaviors are consistent what we have seen in the recent past. You can see that emissions peak in this decade, so in the 20s, and there is a decline of around 10 gigatons of CO2 by 2050, which is this gap. It's not small. This gap is similar to the current level of emissions of South America, Europe, Middle East, and Africa combined. So it's a decline which is significant, but despite this decline, this scenario is not consistent with Paris Agreement. The other scenario, which is represented by this blue line, is what we call net zero. This scenario, it's a what-if scenario. So it's a scenario that tries to answer the question, what elements of the energy system need to change if we want to achieve a reduction of emissions of around 95%. So you can see that in 2050, the level of emissions is almost zero. So it's a scenario which is it's a positive scenario in the sense that a normative scenario in the sense that we try to understand what elements have to be accelerated or have to be different from current trajectory if we want to fully decarbonize the economy by 2050. I want to make the point here that the probability of these two scenarios are zero. So both scenarios are going to be wrong, and because it's impossible to predict the future, as I said at the very beginning. So why are we doing this? I mean, why are we developing and presenting two scenarios which are wrong? For two reasons. First, because the area here between these two lines, this area, capture a wide range of possible outcomes for the energy transition. So, and this helps BP strategies team to design strategies, investment strategies, which are resilient to many possible scenarios in the future. So to many possible outcomes of the energy system in the future. And the other scenario, and the other reason for doing that is, even though net zero and current trajectory are very different scenarios, they are very different. One is a positive scenario, there is a normative scenario. We find trends which are common in both scenarios and give us confidence about what is going to happen in the future. So these are the two reasons. The area between these two lines represent a very wide range of possible scenarios in the future, very possible outcomes, and the other is because we can identify common trends in both scenarios. So before entering in the common trends of those scenarios, let me spend a couple of minutes explaining the economic context. So this chart here shows three different things. First, the red bar represents GDP per capita growth, the average of GDP per capita in the previous 25 years. And you can see that it has been around 2.5 of growth in GDP per capita. The orange bar here represents how much population grew during this period of time, and it was around 1%. And the blue bar represents the improvement in energy efficiency. The first key message of this slide is that total GDP, which is the addition of per capita GDP and population growth, is going to be significantly lower in the future in both the scenarios. So it was around 3.5% in the previous 25 years, and we are expecting something around 2.4% in both the scenarios in the coming years. So GDP is going to grow low. Also, the blue bar that represents improvement in energy efficiency is also larger in both the scenarios. So in the past, in the previous 25 years, economic energy efficiency improved around 1.6 per year as an average growth. In both scenarios, in current trajectories, improving around 2.4, and in net zeros are improving around 3.5. So there is an acceleration in both the scenarios of energy efficiency. As a result, and this is the key message, primary energy, so total demand, increased around 2% in the previous 25 years. And you can see this represented by this white dot in the middle. In current trajectory, we expect a very small increase, almost zero, in the next 25 years. So from now to 25, in current trajectory, and a 1% decline in net zero. So this is the message. So as a result of this combination of lower GDP growth and higher energy efficiency, the growth in primary energy is going to be very different in the next 25 years. To summarize this, in current trajectory, primary energy is increasing to the equivalent of 1 European Union, and in net zero, total primary energy is declining to the equivalent of 3 European Unions. This is the other chart that I want to show, and shows the change in primary energy by region. And you can see three different colors for the bars. The yellow represents the change of emerging economies excluding China. The green bar represents developed economies, and the blue bar represents China. The key message from this chart is that all the growth, it's coming from emerging economies excluding China's. In both scenarios, for China and developed economies, we expect a decline in primary energy. In net zero, we expect an increase of 45% in current trajectory between now and 35 for emerging economies, as I said, excluding China, which is this yellow bar here. And in net zero, the decline is relatively small, it's around 10%. So this is the second message from this slide. So in the first chart is showing that primary energy is going to have no growth, or it's going to decline 1% per year. The second chart is telling us any growth that is going to happen in primary energy is going to be the result of higher primary energy demand in emerging economies due to higher prosperity. Around 70% of the growth, GDP growth, is coming from this type of economies. So this is all I want to say about the total, the macroeconomic context. So going to the common threads. So this is, I think, an interesting story. It's that in both scenarios, we are moving from an energy addition phase of the energy transition to an energy substitution phase of the energy transition. You know that renewable energy has been growing very fast. Renewable energy is represented in this chart by this orange bar here at the top end. But despite this rapid growth in primary energy, we also see an increase in the amount of energy which is unabated fossil fuels, so fossil fuels which are consumed and emissions are not captured, which is represented by this gray bar. As a result of this combination of strong increase in renewable growth, but also strong increase in unabated fossil fuels, emissions between at the beginning of the 20th century, so year 2000 and 2023, is an increase in global emissions by 50%. So what do we see for the future? So in current trajectory, you can see that the orange bar representing the growth of renewable energy is still very large, but even in the next, between now and 2030, from the beginning of 2020s to 2030, unabated fossil fuels are still increasing. So we are in this phase of the energy transition where we see an increase in fossil fuels. By the way, it's important to understand that this type of energy transition has been the historical transition in the past. So when we moved in the 19th centuries from biomass to coal, we saw this type of behavior, so larger, accelerating demand for coal, but still the demand for biomass didn't reduce. And when we moved from coal to oil in the 20th century, it was the same. So there was an increase in an acceleration in oil demand, but demand for coal didn't decrease. And this is what still we are seeing today, and we are going to see for the next 5 years, 5-6 years in current trajectory. This is different in the 20s, 30s, and the 20s, 40s. There is a much rapid increase of renewable energy, and this combined with energy efficiency allows for the crowding out or displacement of unabated fossil fuels. And this is why we see in current trajectory a decline in emissions. When we move to net zero, what we see is that this trend is accelerated, and even in the next 5 years, if we transition to net zero, there is a decline in unabated fossil fuels, which is much larger in the 20s, 30s, and the 20s, 40s than the one that we see in current trajectory as the result of larger deployment of renewable energy, and an acceleration in energy efficiency. In fact, unabated fossil fuels today represent 80% of total primary energy, and in net zero in 2050, they represent only 50%. In the other scenarios, so in current trajectory, unabated fossil fuels still represent about 2/3 of the total primary energy consumed. So this is all I want to say about this energy transition from, energy addition to energy substitution phase. This is the first common trend that we see in the future. So the energy system in both scenarios is moving from energy addition phase to an energy substitution phase of the energy transition. The second element that is common for both scenarios is electrification. So electricity demand is increasing between 75% and 90% in both scenarios. The largest boost is coming from emerging economies, especially from India, and electricity demand in India is multiplying by a factor of 3 in 3 scenarios, but also in developed economies. And if you remember from the previous slide, demand of primary energy demand in emerging economies is declining, but electrification is accelerating also by a factor of 3. So in the previous decade, electricity demand was increasing by around 0.5% in developed economies, and it's now increasing around 1.5 in both scenarios. So it's a multiplication by 3. As a result, the penetration of electricity, and this is what you can see in this chart, is moving from around 25 or 22% today to something between 35 and 55% in 2050, depending on the scenario. The other key element of this electrification is the sharp increase in wind and solar. You can see here two bars. The purple bar represents total power generation, and you can see the increase in both scenarios, multiplying between 70 and 90%. And the blue bar represents the penetration of wind and solar. So it's moving from something around 10% today, 10-12% today, to something between 45 and 65% in current trajectory and net zero. So the key takeaway of this slide is that we are going to see a rapid electrification of the energy system, and this energy system is going to be supported, this electrification, by a rapid penetration of wind and solar technologies. The second trend that we see in the energy system is a decline in oil in both scenarios. Still, between now and 2035, you can see these 2 points represent oil demand, which is around 100 million barrels per oil, 1 million barrels per day of demand today. And in 2035 is still around 100 million barrels per oil, 100 million barrels per day, MBD. I'm going to simplify this. In 2035 and 80, so still oil is playing a critical role in the energy system in the next 10 years. And it is true that in 2050, oil demand is around 75 million barrels per day in current trajectory, and only around 30. So there is a big gap in these two scenarios. In 2050, it's only around 35 million. So depending in which path the economy moves, in 2050 you will see that oil is still a large source of primary energy to fuel energy demand, or it's decreasing its importance substantially materially or substantially if we are moving towards a net zero scenario. Why do we see this large gap between these two scenarios? And the reason has to do with what is mainly explained, or the main driver is road transport, which is represented in this chart that shows the change in oil demand by sector by the yellow bar here. So you can see that the yellow bar explains most of the difference between both scenarios. So in city in 2050, there is a decline of around 15 million barrels of oil per day, and this is the result of two things. First, improving efficiency in the short term, and electrification of the road transport fleet in the second part of the energy outlook. So to give a sense of the magnitude of this decline, is around 40 millions of these 100 millions that we are consuming today, 40 millions correspond to road transport. This decline to 25 millions in current trajectory and to 5 millions in net zero. And the number of electric vehicles that we have in both scenarios is between 1.2% billion of electric vehicles that we have in current trajectory. The total of cars and vans in these scenarios is 2.5, and around 2 billion is the number of electric vehicles that we have in net zero, of a total of 2.5 again vehicles, so cars and vans in this scenario. So there is a much rapid electrification in net zero, and this is why there is even for the conventional car, there is a significant increase in the vehicle efficiency. So efficiency of and consume much less oil per kilometer travel. And this is all I want to say. So the key message is oil demand is going to be still very significant between now and 2035. Declining in both scenarios, significant difference between both scenarios, and the main driver for that is the different view that we have on electric vehicles for road transport. The third common trend that we have in both scenarios is the decline in coal consumption in both scenarios. In current trajectory, there is a decline of around 3/4 of consumption. Sorry, around 1/3 of consumption is declining in current trajectory, 85% decline in net zero. And the main reason for this is explained by China. So China, which is represented in the blue line here, explains most of the decline in coal in both scenarios. In China, so it represents 90% of the accounts for 90% of the decline in net zero, of the global decline in current trajectory. You can see here in this blue bar, which is massive, and around 60% of the decline, it's represented by China also in net zero. And the question maybe is, why is not emerging economies, because the decline in net zero in developed economies is large, why is not a larger decline in coal consumption in developed economies? And the reason for that is that coal is still very resilient in emerging economies outside China, in particular in India and other Asian economies, as they industrialize and electrify very quickly. So key message from this slide, both scenarios have a significant decline in coal consumptions, we see a decline in coal consumption, which is very large in the case of China as a result of more efficiency use of energy in China, and also a decline in coal consumption in the power sector in China. Now, I'm going to go very quickly with this slide. I don't want to run out of time. So this is natural gas. In natural gas, you can see that this chart is very different from the other three I saw before. So this represents the green line represent natural gas demand in current trajectory, and you can see that there is an increase of around 20% in natural gas consumption in this scenario, while in the blue line, which is representing, it represents here the natural gas demand in net zero, there is a 50% decline. Well, I'm not going to enter to explain this chart, but this is the result of two opposing forces. We see that industrialization in emerging economies and prosperity and electrification in both scenarios is demanding or is crowding in natural gas demand. However, decarbonization of the power sector and energy efficiency in industry is crowding out natural gas also in both scenarios. In current trajectory, electrification and industrialization is more significant, and this is why we see an increase in natural gas demand. In net zero, energy efficiency and decarbonization of the power system explains the decline in power in natural gas demand. But the key message of this slide is that the view for natural gas relies a lot or is dependent on the path that you think or the world is going to take in the future. So if you think that the world is going to take a net zero path or something close to net zero, natural gas is going to decline a lot. If you think that the world is going to transition in a path which is consistent with net zero, with current trajectory, you think that natural gas is going to be a very resilient fossil fuels. I'm not going to explain this. This is about hydrogen. I want to have time for you to ask questions. But have in mind that can you see me now? Hello?
We can see the slide.
You can see the slide.
We can see the slide, low carbon.
Okay, so sorry, there was an interruption here. Moving, I'm going to explain very quickly that in particular, hydrogen is also very path dependent. So you can see that there is a significant difference between these two bars here at the bottom, and the reason is, well, in net zero there is an increase in low carbon hydrogen, which is not the case in the other case. So to give a sense of the magnitude of this bar, which is 400 million tons of hydrogen, it is equivalent to 3 times all the primary energy which is consumed by a country like Italy today. Moving to the last slide, which is accelerating the energy transition. This is the chart showing I don't know why this is not working. Okay, so this is the slide you have seen at the very beginning, which represents total emissions in current trajectory and net zero. And I'm going to explain how to move from one scenario to another. So this area that you can see here is the change that is explained between both scenarios because the power sector is decarbonizing. And this represents around 45% of the total gap between both scenarios. It's important to highlight that in developed economies, in both scenarios, the power sector is fully decarbonized by 2050. So this gap is explained totally due to the faster decarbonization of the power sector in power economies. This second area, which is marked here in red, represents the additional gap between both scenarios explained by a faster decarbonization of energy. If we know very well what you need to do in the power sector, which is basically remove coal and natural gas consumption by renewable energy, the movement here, or the area explained by the red area here, which is industry, is the combination of many different factors. There is no silver bullet here. It's the combination of more energy efficiency in industry, electrification of light industry. It's also the deployment of carbon capture and storage in the cement sector, so in the sector of production of cement and concrete. And the same thing for steel and the use of low carbon hydrogen. These two explain around 80–90% of the gap between two scenarios. The other gap is more electrification and more electric vehicles in transport and more electrification in buildings. But you can see that all the effort should be put in a faster decarbonization of the power sector and decarbonization of industry. The gap between in both scenarios for transport and buildings is much residual. And this is the last slide of the presentation. So Elisa, I'm going to pass you the floor. 4 elements of the energy we need to do for decarbonize. First is that the world needs to decarbonize, and by the world it means totally not only developed economies and China, also emerging economies needs to decarbonize. The second is that we need to pay much more attention to energy efficiency. Energy efficiency, it's the forecasting in the policy normally, or the, I'm going to say this in Italian, so I hope it's correct, the fratello dimenticato in Italian, so the element that you never pay attention to in policy, and it's key to achieve net zero transition. The third element is we need to decarbonize power sector in emerging economies and also developed economies. And the last key message is that it's all about application, not invasion. So I'm sure there's going to be amazing and incredible technological advances in the energy system in the next 25 years. But to achieve net zero emissions, we need all the elements are here that we need to decarbonize. So it's more energy efficiency, more wind and solar, and apply carbon capture and storage. And this is all I want to say. So I finish here the presentation. So you have now the floor. So thank you very much for your attention, Elisa. Elisa, it's your turn.
Thank you very much, Jorge. I immediately switch to Elisa for her comments. Elisa.
Thank you, Jorge. Thank you, Marzio and Alessandro, for inviting me. Jorge gave us a lot of content, a lot of food for thoughts. I will try to give my comments as well, scatteredly. I prepare, let's say, 8 points that I believe are important to take in mind in order to understand the implication of this scenario. As Jorge presented at the beginning, so we are talking about scenarios, not forecast. And they are very useful. First of all, because these scenarios allows us to run a reality check. I have been listening to these words very frequently in the last few months, reality check. It's very important because by looking at actual data and looking at what has been achieved of the policy target, we can take care and understand the path in the future. So it's very important to keep in mind the effectiveness of the policy measure. In fact, the first feeling that I had when I downloaded the BP Outlook, as Jorge mentioned, you can download it for free, and I suggest you to take a look because it's very useful to capture and to understand the future development of the energy transition. The first impression I got, not only reading BP Energy Outlook, but also other think tank scenario, is that total energy demand is not evolving along the trajectory that we predicted a couple of years ago. So it's very important to take care to understand where we are now and how we can move forward. Another point that I would like to stress very briefly is that when we drive long-term scenarios, we usually assume constant growth rate. That means that, in other words, we are drawing a linear way the future. However, short-term uncertainties, just have in mind what happened with the energy crisis, with the invasion of Ukraine by Russia, put us in different situation. So what we have seen is that we can have different speed for reaching the net zero goals, and that's another thing we need to take into consideration. The second point I want to stress is the trilemma of energy policymakers. It's important to highlight that global energy system need not only to be environmentally sustainable, but also secure and equitable. And regarding energy equity, a country must implement measures to provide universal access to affordable, fairly priced, and abundant energy. And the diversification of energy supply can help in improving energy security, but we need to bear in mind that we can have major issues such as geopolitical risk and political instability. I've just mentioned the crisis following a Russian invasion of Ukraine that showed the importance to rely on different natural gas suppliers and how local conflicts may spread to other countries. So we need to keep in mind also geopolitical context for what concern raw materials. So we are all talking about the importance of green technology, but at the same time, all these technologies rely on raw materials that are concentrated in a few countries. In particular, wind and solar, for example, are based on rare earth materials whose markets are dominated by China. The third point I will touch very briefly. I can spend more than 2 hours about this, but I believe it's important to mention is the cost of the energy transition. So here we so two different scenarios. We have different costs associated to this scenario, and Jorge talked a lot about electrification, it's important to notice that the decarbonization of the electricity grid and the overall electrification of the energy system represent monumental projects that take a long time to implement. We have very different estimates about the cost of the energy transition. It can range from a total of $100 trillion to $300 trillion between now and 2050. And to give you the idea of this number, just bear in mind that current annual global GDP is about $100 trillion. So we can reach astronomical levels in terms of money needed to grant the transition to happen, and these require or direct financing by utilities and by industry players, or indirect finances. And we get back to the point I was mentioning before of the energy trilemma. So energy must be fairly priced. The fourth point concerns the role of new technology. Jorge was just mentioning a little bit about hydrogen. So I understood reading the Outlook that the Outlook does not consider the role of new technologies, but it includes emerging technologies such as hydrogen and CCS, CCUS. Considering their penetration as given, we must take into consideration that the introduction of these technologies breakthrough has not occurred at a very fast pace. In some countries, unfortunately, where CO2 is portrayed as an harmful greenhouse gas, for example, in Germany, several CCS projects have been cancelled, and we still hear about protests regarding this kind of investment. On the other side, hydrogen, that is often described as a more viable solution, present also different challenges in terms, again, of local groups that can express concerns about the economic sustainability and the potential safety of this kind of technology. So we have to bear in mind that from one positive point, technological progress can be a game changer. We can have new technologies that now we haven't considered analyzing these two scenarios. But at the same time, we must be careful also when considering the moving to hydrogen and CCS. The fifth point is concerned the coordination problems. I believe that cooperation is the key word. We are moving in a world that is going at very different speeds. We have very heterogeneity in terms of consumption and in terms of production as well. For instance, the United States is facing the combined challenges of electrification and decarbonization, and we see, for example, demand increase for the data center. But the country has made great strides to reach the target 100% clean energy by 2035, but is still very far from meeting the target of 20% of electrification of the final energy consumption. On the other side, European countries, we have seen quite a flat trend in the electrification rate in all the countries, although we were moving from a different basis, I would say. So right now, total electricity made up only a tiny fraction of all the energy consumed in Europe, around 33%. And we still have, I would say, challenges concerning the electric vehicles and all the charging infrastructure. On the other side, we have all the emerging countries that still need to move to classes of electricity and of energy in general. So in this context, global collaboration should be a powerful driver for the development and the adoption of ambitious policies. Let me just give other two elements. One is the role of carbon markets. I've been thinking about the role of carbon markets quite a lot during the few months. Again, because we have the world split in two different situations. We have some countries where the market for carbon doesn't exist, or they are in the progress to introduce it, like China. And we are in, we can take as an example Europe, where on the opposite side, we are moving towards a lot of subsidies, incentives, and support measures for all the different energy sources that we want to introduce, renewable batteries, and so on. So in this framework, we need to rethink about the role of carbon market in helping reaching the transition. Then very briefly, the importance of transition fuel. I believe that we still need to understand the correct role for gas and for nuclear in the way toward the transition. My last point concerns demand. Jorge presented the scenario for coal, for gas, for oil. If we have a look at the different providers, we can see very different scenarios for the future in terms of demand. Just give an example. If we take OPEC outlook, we have a very optimistic forecast of demand that reaches 116 million barrels per day in 2045. So I believe that together with the different sources, the different supply sources, demand is still the key to reach the transition, and the policy measure must be very focused on this, together with the increase in awareness of the consumption. That's all from my side.
Thank you very much, Elisa, for your very rich discussion and comments. I think that the best thing to do before closing is to ask Jorge to react to your comments, and I let Jorge to make a choice, make a selection. Also, given that the time is running, Jorge.
Well, it has been a really deep comment, so that there is many elements that I could comment on, but let me just.
You have 5 minutes, Jorge. 5 minutes.
No. I'm going to use a couple of minutes only. Thank you very much. So there is something which I like it a lot, which is the idea of reality check. So what is possible, what is not possible, to what extent these scenarios are connected with reality or not. And I mean, I didn't have time to explain of the energy outlook, but the first thing that we start the document of this year is to explaining things that we have been surprised, or what are the elements of the energy transition in the last 2 years that has been more interesting and surprising for that. And there has been 3. The first one has been something that Elisa has mentioned, which is the demand has been much more stronger than we have thought. So 2022, 2023, once we pass the pandemic, there has been a much stronger growth that we thought, and we have to adjust all our scenarios, the amount of energy demanded, the amount of oil, gas, even renewables, to reflect this new reality. And I am sure that from now in 1 year, reality is going to again tell us, well, these scenarios need to change to pass this reality check. The second element, which I think it's also interesting, I think it has been mentioned about policy, is the impact that the steel, Ukraine, and energy security has on demand and on policies, in particular on European policies about decarbonization and on European policies to support different type of energies, carbon, subsidies, this thing. I mean, Elisa has mentioned we have moved from carbon prices to subsidies, and I think this is reflecting again a reality check saying carbon prices are not enough. Carbon prices push for decarbonization, but we need also to enhance, to accelerate our security. And the third comment is very is again a reality check, is emissions are still growing. In 2023, emissions in China, for example, grew by 6%, in India by 9%. And again, reality is there, and we need to design scenarios, but the scenario has to be credible. I fully agree, and thank you for comments, Elisa. They have been really good and deep ones. So thank you very much. And I stop here.
Okay, thank you very much, Jorge, and thank you very much, Elisa. This was the presentation by Jorge Blasquez of the BP Energy Outlook. We hope there will be another occasion next time for the new BP Energy Outlook. I thank everybody for attending, and I give the floor to the Director Lanza for the closing.
Yeah, the closing is very simple. Thank you all again, and also thank you to the people that was connected to this initiative. Also because, as you know, you have just an example, 200 people that registered and then they disappear. Next time their presence has been persistent, which is a proof that the organization was well done. I didn't have any doubt in the professionalism of our people, but also the discussion was rich, well presented, well discussed, and so on and so forth. So thank again to the participants, starting from Jorge, Elisa, and all the rest. And we will stop in August, but we will be back in September. Stay tuned. Thank you very much.
Thank you.
Ciao.
Bye.